Good morning everyone, I am Meenaka. In today's class we are going to discuss the example sum for programmable logic array PLA. So here is the question, implement the following function using PLA. So here in question they given the three boolean function expression f1 equal to summation of minterm 1, 2, 4, 6 and for the boolean function f2 summation of minterm 0, 1, 6 and 7 and f3 minterm 2 and 6. Here the summation represent the question given us in SOP, sum of product term. So for implementation of PLA, first step was we are going to construct a truth table. If you observe from the question, the maximum minterm is 7. So we are going to take n equal to 3. N equal to 3 is number of variables. So here we are going to take 3 variables. So 2 power 3 equal to 8. That is 0 to 7. So if it is more than 9 or 10, so we are going to take n equal to 4. So 2 power 4. So likewise. So here since we are taking 3 variables, 2 power n equal to 8. That is 8 possible inputs. So 0 to 7. Here 3 input I am taking as A, B, C and whatever variable you want you can take. If suppose they mentioned in question you have to take respective input variable. So here A, B, C we know the possible input combinations. That is 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. For easy plotting the minterms, I am going to mention M0, M1, M2, M3, M4, M5, M6 and 7. So this is the input and output. What are the output function? F1, F2 and F3. So I am going to mention the output variables F1, F2 and F3. So for the boolean function F1, what are the minterms present? I am going to plot 1. Since this is SOP. If it is POS, I am going to plot 0 for the given max term. So for F1, what are the given minterms here? Minterm 1, 2, 4, 6. For the respective minterm, I am going to plot 1. 1, 2, 4 and 6. Remaining, I am going to plot 0. Likewise, I am going to plot for boolean function F2 and function F3. For F2, what are the given minterms? 0, 1, 6 and 7. For those alone, I am going to represent 1, 0, 1, 6 and 7. Remaining 0. For F3, just 2 minterms, 2 and 6. So 1 and 1. So remaining. So first step we constructed the truth table. Next, step 2. Step 2, simplification of K-map. We are going to plot the given minterms in the K-map, group it and minimize the expression. So for first step F1, I am going to draw the K-map. Since this is 3 variable input, I am going to draw the basic 3 variable K-map structure. So what is basic 3 variable K-map structure? This is the basic 3 variable K-map structure, you have to know it. And what are the input we mentioned here? A, B, C. A, B, C. So for A, what are the combination? 0 and 1. Since this is 1 bit. And if it is 2 bit, what are the possible inputs? 0, 0, 0, 1, 1, 1 and 1, 0. Usually we will write 1, 0 and 1, 1. But for K-map, this is the basic structure. Since if you put 0, 1 after that, 1, 0 means it will be 2 2-bit change occurs at the same time, it's not correct and valid. So that's why we are interchanging this and this to make single bit change. Now we can plot it on the K-map. 0, 1, 2, 3, 4, 5, 6. This is the meantime designations. So basic K-map structure for 3 variables done. Now second step for K-map is we are going to plot the given mean term, which is mentioned in the question. For F1, what are the given mean term? 1, 2, 4, 6. For that cell alone, I am going to mention plot 1 inside. So 1, 2, 4, 6. 1, 2, 4, 6. Now we draw the basic structure of K-map. Then we plotted the given mean terms in the respective cell. Next, we are going to group the ones. First, we are going to check for 4 ones. If any possibility of 4 ones is possible here. No. So then check for 2 ones. What are the 2 ones possibility? We are going to group. So this 2 ones. Check. We have to check horizontally, vertically, folding horizontally and folding vertically. So we are going to check in all the aspects. So first, I am going to see the first combination. So while grouping, check horizontally and vertically. I am going to write the product. So while checking horizontally, it's going to cancel. Now check vertically. So what is, for easy understanding, you can write like this. Since this is SOP, we know the concept of SOP. For 1, we are going to represent the variable. 0, we are going to represent the complement of variable. For this, A bar, A. B bar, C bar. Here B bar, C. Here B, C. Then B, C bar. Now it's easy to write the product. Now we group the 2 ones, right? So now check horizontally and vertically. While checking horizontally, this 2 will get cancelled, and while checking vertically, both the ones lies in this column. So I am going to consider this. I am going to just write this product. Next, check for any possible 2 ones combinations. So yeah, while folding vertically, you can make this as grouping. Now write product term for this. This 2 ones lies horizontally in the same. What is that? A. Next, we are going to check vertically. So this 2 line fall under this 2 column. So which is common here? We have to check 0, 0 and 1, 0. So C bar is common. So I am going to consider C. This is how we are going to write the product term. Now check whether any possibility for grouping. No. So the single grouping is there. So single one is there. So just I am going to write the product term for this. So what is the product term? A bar, B bar, C. That's it. So grouping is done. Now we are going to write the expression for this. So F1 equal to A bar, B bar, C plus AC bar plus this one done, and this one, B, C. Like this, for F2 and F3, we are going to plot it on K-map and simplify and get the expression. This is our second step. Next, for F2. Again, I am going to draw the 3 variable K-map structure. What variable is given? A, B, C. So 0, 0, 0, 1, 1, 1, 1, 0, 0, 1. Here, this is SOP as I told you earlier. A bar, A. Here, B bar, C bar, B bar, C, B, C and B, C bar. Okay. Now, immediately write the respective midterm designation inside so that it will be easy to plot it. Okay. Now what are the midterms given in F2? 0, 1, 6, 7. 0, 1, 6, 7. So I am going to plot one inside the respective cell. 0, 1, 6 and 7. Okay. Now plotting is done. Now we are going to group. So for grouping, we are going to check from 4 ones, then comes 2 ones. Okay. So any 4 ones possibilities there? No. Then check for 2 ones. So any 2 1 grouping, yeah, this one. So immediately write the product term, so it will be easy. Otherwise it will be a bit clumsy and you will get confused. So okay, so this 2 1s lies in this row. So what is that? A. Next check vertically. So what is that? Which is common here? B, C. Here, 1 1 1 0. That is which is common here for B. This one. So this one is B. I am going to consider B. Okay. Next check any other 2 1s possible is there. Yes. So I am going to group. Now I am going to write the product term. So this 2 1s lies in this same row. What is that? A bar. And now check vertically. So vertical which is common here, the 0. 0 is what? Nothing, B bar. So I am going to write B bar. So now check any other possibility or any single ones is there. No. So that's all. Our expression F2 equal to A bar, B bar plus AB. So this is F2. Likewise, I am going to plot it for F3 also. F3 A, B, C 1 1 0 0 1 A bar A, B bar C bar B bar C, B C, now immediately write the designation inside. Done. Now we are going to plot the given mean terms for F3 function. F3, what is the function? 2, 6. So for those mean term alone I am going to plot one inside. Rest 0, 0 or 2, just you can leave it. Now grouping. So check for 4 ones, there is no possibility for 4 ones grouping. So check for 2 ones. So this one. So how will write the product term for this? You have to check horizontally, then vertically. So check this 2 1s lies in both the rows. So it will be cancelled and check vertically. So what is that? B, C. So no other ones. So that's it. Your F3 equal to B, C bar. So that's all. So second step is done. So simplification of K-map so that plotting out the K-map, grouping, and we got the expression for F1, F2 and F3. So this is your step 2. Then comes step 3. Step 3. Step 3 is we are going to construct an PLA program table. PLA program table. For PLA program table, here first what I do is aside I will write, beside I will write F1, F2, F3. F1 equal to A bar, B bar, C plus So step 3 is we are going to construct a PLA program table. For that, from step 2 we got the minimized expression, right, for F1, F2, F3. So beside I wrote it here, so it will be easy to refer and construct a PLA program table. So first, product term, input, output. So here product term, what all product term is present in F1, F2, F3, I am going to write all the product terms. So what all product terms present in F1? A bar, B bar, C. Then A, C bar. Then B, C bar. F1 is done. So F2, two product term. What are those? A bar, B bar. Then A, B. F3, B, C bar. So here we mention all the product term which is present in your F1, F2, F3. Okay. Suppose if this A bar, B bar, C or any product term repeated again in any other function means we can write only once. Okay, we can skip that and we can skip or ignore and we can write only once. Okay, since here there is no repetitive, I wrote all the product term which is mentioned in F1, F2 and F3. Then input. Input is what? What are the input variables we mentioned here? A, B, C. So what is the output variable? So they mentioned F1, F2, F3 in function, right? That is the output variables. So I am going to mention it here. Okay, done. Now this product term, respective product term A bar, B bar and C bar. So C, this product term is present in F1, F2, F3. I am going to check that and I am going to mention 1. Okay. அது பாஸ் பண்ணுங்களேன், அது ஒரு தப்பு பண்ணிட்டாங்க, நான் எடிட் பண்ணிக்கிறேன். So here the respective product term which are present in F1, F2, F3 I mentioned it here. If the same product term is present in F2 or F3, suppose A, C bar is present in F2, F3, we can write only once. We can ignore that and we can write only once. Okay. So now input A, B, C. So the 3 variables I mentioned it here. Now for the respective product term I am going to check whether the variables are present. If it is complement I am going to mention 0. If it is just a variable I am going to mention 1. If the variable is not there I am going to mention dash. Okay. So here A bar. So A bar means what? 0. B bar means 0 and C 1. Likewise for the rest of the product terms I am going to mention A, C bar. So A is what? 1. C bar, B variable is missing. So it's not there, so I am going to mention dash. C bar 0. Likewise for B, C bar. So B, A variable is missing here, so I am going to mention dash. B 1, C bar 0. Here A bar, B bar. C variable is missing. So A bar 0, B bar 0 and dash. Here next is A, B. So 1, 1 dash. B, C bar. Where A bar A is missing, A variable is missing, so dash 1. This up we are going to mention 1, 0 dash for the inputs by referring your product term. Then comes output F1, F2, F3 variable. So for that this respective min term we are going to check whether it is present in F1, F2, F3. So if it is present in F1 I am going to mention 1, otherwise I am going to mention dash. Here F1 equal to check first for this product term A bar, B bar, C. So this present in F1. So I am going to mention 1. Then check whether it is present in F2. No. So dash dash. I am going to check for F3. It's not present, so I am going to mention dash. A, C bar. Check whether the product term is present in F1. Yes. So I am going to mention 1. So check for F2 and F3. No. So I am going to mention dash. So next comes B, C bar product term. Check for F1. So yeah, it's present. So for F2 and F3, no, so I am going to mention dash. Then A bar, B bar, so check whether it's present in F1, no, so I am going to mention dash. Check for F2, yeah, yes, it's available, so I am going to mention 1. Likewise check for F3, so F3 it's not there, so I am going to mention dash. Then AB product term, so AB product term, it's not in F1 it's not present, so I am going to mention dash. For F2 it's here, so I am going to mention 1. So F3 it's not available, I am going to mention dash. And next BC bar, check for F1. So F1 the term is present, right? Here if you say notice this product term and this product terms both are available in F1 and F3. So we can write it once. So it's repetitive, so I can mention only once. So that's it. This is how we are going to construct the PLA program statement. Next step 4. Step 4 what I am going to do is I am going to draw the logic circuit diagram by referring the expression. We are going to implement the expression, design the logic diagram. For that, beside I am going to write the expressions. So it will be easy for us while referring and drawing the logic circuit diagram. So pass பண்ணுங்க. அது பக்கத்துல எழுதிக்கிறேன் வரையறதுக்கு. So step 4 is designing the logic circuit diagram by referring the Boolean expression. So what are the three variables A, B, C? So I am going to draw a buffer for that. This is A. This represents as 1 and 0. That is, this is A and this is A bar for B. So here three variable A, B, C. So this is 1, 0. That is A, A bar. B, B bar. C, C bar. Okay. Now referring the F1 function. A bar, B bar, C. That is product term. Here, so this is PLA. That is programmable logic array. Both your OR gate array and AND gate. That is product term and sum term. Both are programmable. Both are programmable. Here in PLA both OR and AND gate array are programmed. So that is program means while plotting it on the circuit diagram I am going to just mention a cross. If it is fixed I am going to represent by dot. So, okay. So program means I am going to represent by into a cross symbol. If it is fixed I am going to represent by dot. Okay. Now F1. So what are the product term? A bar, B bar, C and A, C bar and B, C bar. So first is A bar, B bar, C. A bar, here it is A bar. Then B bar, this is B bar. Then C. This is what? And gate array. So I mention. So parallelly mention the product term for the respective AND gate. So what are the product term? A bar, B bar, C. Likewise, I am going to draw plot for rest of the product term. A, C bar. This is A, C bar. Then B, C bar. B. This is B, C bar. Okay, so F1 is done. F2, A bar, B bar. A bar, B bar. Then AB. A, B. While plotting A bar and A, that is variable and complement of variable, be careful. So if you make, even if you make mistakes, so the whole product will go wrong. The circuit diagram will be end up wrongly. So next for F3, B, C bar. So B, C bar. So next. So product term is done. Next, sum. That is F1. What are the product terms is available in F1? This one A bar, B bar, C, A, C bar, B, C bar. Okay. So I'm going to mention that. So this is what? Again, AND gate and OR gate is programmable. I'm going to mention a cross if it is present in your F1. So what are the product terms present in F1? A bar, B bar, C bar. Then A C bar, then B C bar, B C bar. Okay, so what is that? Or this is F1. Then F2, A bar, B bar. This product term, then A, B, this product term. This is F2. Then F3, only B, C bar. Only this. So this is the step we are going to implement the programmable logic array. So finally I will summarize that. Step 1 we are going to construct the truth table, and step 2 we are going to simplify the K-map, and step 3 we are going to construct the PLA product table, and step 4 referring that I am going to draw the logic circuit diagram. So this is how we are going to implement and design the PLA. So this is one model. In next class we can discuss about model 2. Thank you.